Welcome to the Trend Micro Deep Security 10 for Administrators video series. This collection of videos provides an overview of tasks that may be required as part of your work as an administrator in Deep Security Manager. The Deep Security Firewall Protection module ensures that packets originating from unauthorized sources do not reach applications on a protected server. In this video lesson, we will enable the Firewall Protection module and configure rules to block or allow packets. Firewall rules examine the control information in the first packet of an exchange. The rules either block or allow the packets based on their settings. Firewall rules are assigned directly to computers or to policies, which in turn are assigned to a computer or collection of computers. Let's go into the Deep Security Manager web console and take a look at some of the configuration settings for firewall rules. I've logged into the Deep Security Manager web console as an administrator, and let's take a look at some of the Firewall Protection module settings that are available for a policy. On the menu, click Policies, and in the Policies list, double-click one of the policies to bring up the details. In this case, I've created a custom policy called Classroom. In the left-hand frame, click the Firewall Protection module, and note the firewall state is currently set to Off. In this case, the state is inherited from a parent policy, which in this case is the base policy. So at the classroom level, what I'll do is I'll enable the policy and click Save. Now notice that there are 4 rules that are currently enabled. If you take a look in the Assigned Firewall Rules section, you'll notice that you have 4 rules. Click Assign Unassign, and you'll notice that these rules are selected and grayed out. That means that you cannot disable these rules at this level. If you remember one of our concepts related to policy inheritance, any rules that are assigned to a policy and are inherited from a parent policy cannot be disabled at this level. You would have to go into the parent policy, which in this case is the base policy, and disable the rules there. This was designed so that anytime the Firewall Protection module is turned on in any of the children policies, they will automatically enforce these 4 rules. Click Assign Unassign, and let's take a look at some of the options that are available when you create a new rule. So under New, let's click New Firewall Rule. So the first field that's available is a name for the rule. So I'm just going to give this a sample name. So let's call this the sample demo rule. In the description field, type a short description for the rule. This will be handy for other administrators who will be coming along at a point later in time to help them understand the reason for this particular rule. The first setting you're going to enable in your rule is the action. There are 5 possible actions that are available. The first action is deny. Firewall rules using the deny action explicitly block traffic that matches the rule. Firewall rules using the allow action explicitly allow traffic that matches the rule to pass through the firewall and then implicitly denies everything else. If you have no firewall rules using allow in effect on a computer, all traffic is permitted unless it is specifically blocked by a rule using the deny action. Once you create a rule using allow, all other traffic is blocked unless it meets the requirement of this rule. The bypass action allows traffic to bypass both firewall and intrusion prevention analysis. Only the port, direction, and protocol can be set with this action. Bypass is designed for media-intensive protocols where filtering by the firewall or intrusion prevention modules is neither required nor desired. Firewall rules using bypass have the following characteristics. Bypass skips both firewall and intrusion prevention analysis. Since stateful inspection is skipped for bypass traffic, bypassing traffic in one direction does not automatically bypass the response in the other direction. As a result, firewall rules using bypass are always created in pairs, one for incoming traffic and another for outgoing. Firewall rules using bypass will not be logged. Firewall rules using the log-only action will only generate an event if the packet in question is not subsequently stopped by either a rule using a deny action or a rule using an allow action that excludes it. If the packet is stopped by one of these two actions, those rules will generate the event and not the rule using the log-only action. If no subsequent rules stop the packet, the rule using log-only will generate an event. And finally, firewall rules using the force allow action exclude a subset of traffic that could otherwise have been covered by a deny action. Force allow has the same effect as bypass. However, unlike bypass, traffic that passes the firewall because of this action is still subject to intrusion prevention scanning. The force allow action is particularly useful for making sure that essential network services are able to communicate with the deep security agent computer. Firewall rules using force allow should only be used in conjunction with rules using allow and deny actions to allow a subset of traffic that has been prohibited by these rules. If you have selected force allow, deny, or bypass as your rule action, you can set a priority of 0 to 4, with 0 being a low priority and 4 being the highest priority. Setting a priority allows you to combine the actions of rules to achieve a cascading rule effect. The priority determines the order in which rules are applied. High priority rules get applied before low priority rules. For example, a port 80 incoming rule with a deny action with a priority of 3 will drop a packet before a port 80 incoming rule using force allow with a priority of 2 ever gets applied to it. Note in this illustration that log-only rules always have a priority of 4, so they will always be processed first, and allow rules have a priority of 0 and will always be processed last before the traffic gets passed off to the application. The deep security firewall is a bidirectional firewall. Therefore, it is able to enforce rules on traffic originating from the network to the deep security host, referred to as incoming, and traffic from the host to the network, referred to as outgoing. From the packet direction list, select whether you would like this rule to apply to traffic that is incoming or traffic that is outgoing. Firewall rules only apply to a single direction. Therefore, firewall rules for specific types of traffic often come in pairs. Next, in your firewall rule, select the frame type. The term frame refers to Ethernet frames, and the available protocols specify the data that this frame carries. When selecting a frame type, you have the option to also use not to specify whether you will be filtering for this frame type or anything but this frame type. In this example, let's leave it at IP. Then in the protocol list, you can select the protocol where you will specify the transport protocol that your rule will look for. For example, let's say TCP. The next section of the rule will allow you to identify the source of the packet or the destination of the packet. The firewall rule can specify an IP address, a MAC address, or a port to determine traffic source and destination. If you have selected TCP or ICMP as your protocol, you can choose to direct your firewall rule to watch for specific flags. If the rule does not apply to all flags, you can choose from these specific flags, including urgent, acknowledgement, flush buffer, reset, synchronize, and finish. And finally, if desired, you can disable logging of events triggered by this firewall rule. Click OK, and the firewall rule is now added to the list, and you can filter the list to only show the assigned firewall rules, and in this case, there is your new sample demo rule. Deep security firewall rules have both a rule action and a rule priority. Used in conjunction, these two properties allow you to create very flexible and powerful rule sets. Unlike rule sets used by other firewalls, which may require that the rules be defined in the order in which they should be run, deep security firewall rules are run in an order based on the rule action and the rule priority, which is independent of the order in which they are defined or assigned. When the deep security firewall is initially enabled, it behaves as a permissive firewall, permitting all traffic by default and only blocks traffic believed to be malicious based on signatures or other information. Implementing a firewall rule using the allow action will cause all other traffic not specifically covered by the rule to be denied. A firewall rule using the deny action can be implemented over a rule with an allow action to block specific types of traffic. A firewall rule using the force allow action can be placed over the denied traffic to allow certain exceptions to pass through. Packets arriving at a computer get processed first by the firewall rule, then firewall stateful configuration conditions, and finally by the intrusion prevention rules. If there are no rules using the allow action in effect on a computer, all traffic is permitted unless it is specifically blocked by a rule with the deny action. Once a single rule using allow is created, all other traffic is blocked unless it meets the condition of that rule. Port scanning allows administrators to detect open and potentially vulnerable ports on machines on the company network. This functionality can be used for a few different purposes. For example, they can aid in the selection of firewall rules to apply. They can evaluate the effectiveness of existing firewall rules. And when used in combination with malware-specific port lists, they can detect the ports that have been opened by malware. Deep Security Manager checks for open ports by initiating connections with them. If a connection is established, then the port is identified as open. In the computers list, right mouse click on the computer you would like to scan, click on Actions, and scan for open ports. You'll notice in the task list, scanning for open ports is displayed, and in the lower left-hand corner, we're scanning for open ports on one computer. It'll just take a moment for the scan to complete, and then we'll take a look at the details for this computer to see which ports are currently open. This scan is complete. Let's double-click on the computer to view the details. Click on the Firewall Protection module on the left-hand side, and notice on this machine we have port 53, 80, 135, 139, 443, 445, and 4118 that are currently open. If any of these ports should not be left open, you can then create a firewall rule to block the traffic to that port. Deep Security can implement two modes for intercepting traffic at their hosts. Traffic analysis takes place whichever mode is used. Under the Network Engine mode, there are two options that are available: Inline and Tap. When in tap mode, live packet streams are replicated and diverted from the main screen. In tap mode, the live stream is not modified. All operations are performed on the replicated stream. When in tap mode, deep security offers no protection beyond providing a record of events. It's a good idea to test your firewall rules in tap mode, and once you are satisfied that the rules are working correctly, switch to inline mode. When operating using inline mode, the live packet stream passes through the network engine. Stateful tables are maintained, firewall rules are applied, and traffic normalization is carried out so that intrusion prevention rules can be applied to payload content. Only the inline mode provides security functionality. In some cases, the network engine blocks packets before the firewall rules can be applied. By default, the network engine blocks packets if the deep security agent has a system problem, for example, it's out of memory, or if the packet sanity check fails. This fail closed behavior offers a high level of security as it ensures that cyber attacks cannot protect your network when an agent or a virtual appliance is not functioning properly, and safeguards against potentially malicious packets. The drawback to failed closed is that your services and applications might become unavailable because of problems on the deep security agent. You might also experience performance issues if a large number of packets are being dropped unnecessarily as a result of the packet sanity check locating too many false positives. If you have concerns about service availability, in Feature Release 2, you can change the default behavior to allow packets through, or what is referred to as fail open, for system and packet check failures. Set Network Engine System Fail to fail open to allow packets through if the network host experiences problems such as out-of-memory failures, allocated memory failures, or network engine decoding failures. Set the Network Packet Sanity Check failure to fail open to allow packets through that fail the network engine sanity check. Anti-evasion settings control the network engine handling of abnormal ports that may be attempting to evade analysis. Anti-evasion settings are configured in a policy or on an individual computer. The anti-evasion posture settings control how rigorous intrusion prevention analyzes packets and can be set to one of the following values. Normal prevents the evasion of intrusion prevention rules without false positives. This is the default behavior. Strict performs more stringent checking than normal mode, but can produce some false positive results. Strict mode is useful for penetration testing, but should not be enabled under normal circumstances. If you select Custom, additional settings are available that enable you to specify how deep security will handle issues with packets. For these settings, the options are Allow, in which deep security sends the packet through the system, Log Only, which will provide the same behavior as Allow, but an event is logged, Deny, where deep security drops the packet and logs an event, or Deny Silent, and this is the same behavior as deny, but no event is logged. Under Firewall, on the Reconnaissance Scan, in this step, you can set up the driver to detect possible reconnaissance scans that attackers often use to discover weaknesses before beginning a targeted attack. Set the reconnaissance scan detection to Yes, and then for each of the different types of reconnaissance scans, you can indicate a time period to block traffic. For example, if there's a operating system fingerprint probe that's attempted against this computer, the deep security agent will block traffic for 5 minutes. And finally, the stateful configuration analyzes each packet in the context of traffic history, correctness of TCP and IP header values, and TCP connection state transitions. In the case of stateless protocols like UDP and ICMP, a pseudo-stateful mechanism is implemented based on historical traffic analysis. A packet is passed to the stateful routine if it has been allowed through by a static firewall rule condition. Under Firewall Stateful Configurations, select the configuration from the list. These have been created as common objects and can be selected, or you can create a new firewall stateful configuration. This completes the filtering traffic using firewall rules lesson as part of the Trend Micro Deep Security 10 for Administrators video series.